So we leave 1 plus 5x. We can't combine 1 and 5x, so we just leave that alone. Okay. For the next one, let me get the laser thingamajig. Here we have these three terms, right? Well, notice that these two are like terms, right? They're both degree 3, right? The exponents of x are both 3. They're like terms. They're both in the variable x, and they have the same exponent of x. So these two we can combine. That's what I'm doing here. The 5x squared, that's a term of degree 2. Okay. So first we take care of the terms of degree 3, those two like terms. We combine them, right? We're subtracting the coefficients. We get negative 8x cubed. Okay. What about this 5x squared? It's still there. We can't combine these, right? These are not like terms. This is degree 3. This is degree 2. So they're not like terms. So what do? Leave them alone. Are there any questions on this? Okay. Now for monomials, what we end up with are polynomials. Essentially a polynomial in the variable x is just any sum of monomials in the same variable x. In other words, you're taking some monomials and just adding them together. That's what a polynomial is. And there's a lot of there are some conventions here. For one, it does turn out you can write a polynomial in this way, where if you read this from left to right, the powers of x, they're decreasing as you go from left to right. This is n, we have n minus 1, and so on. Okay. Now, the biggest power of x, the n here, assuming this a sub n is not 0, we say n is the degree of the polynomial. In other words, the degree of a polynomial is the biggest exponent of x. And the term with the biggest exponent of x, that's this a sub n, x to the n. That's called the leading term. This a sub n here is called the leading coefficient. And this a sub 0, we call it the constant term. There's no variable there. Okay, we have like we're out of time now. I'll start from here next time. So on Friday, we'll start from this slide. So let me stop.